Thank you for taking the time to watch this addition and subtraction handy hints guide for parents. Hopefully it'll be useful and informative and give you the guidance on how we introduce early addition and subtraction strategies. For more formalised subtraction strategies, watch the second video that comes after this, where we talk about exchanging and the importance of using language such as tens and ones. To begin then, I'm going to share my screen and I'm going to show you a presentation that I've created to help explain. You can see here in front of you, there is a group of cats, a group of 6. We know that 6 is the whole, and to work this out, we can see that 2 is a part of our whole and 4 is a part, and together the whole is 6. 2 is a part, 4 is a part, and 6 is the whole. 2 plus 4 equals 6. 6 equals 2 and 4. Notice how when we show children calculation, we also start with an addition and also with the answer. That sometimes is a really interesting way to help children understand that the sum can be done in lots of different ways. Moving forward, the 6 is still my whole. Now we want the children to recognise that 4 is a part and 2 is a part. So you might think it's just a small step that 2 is a part and 4 is a part, but they also need to recognise that the addition can be done in a different order and still get the same answer. 4 plus 2 equals 6. 6 is the same as 4 and 2. So teaching in this way, children begin to understand that 2 add 4 is the same as 4 and 2. And this is a more literal pictorial representation of that. 2 and 4 is the same as 4 and 2. Another method for addition is the first, then next, or now. And you can see that on the bus, there's first of all 1 person, 6 people get on, and now there are 7 people, and it's a slightly different strategy when we're working this out. First there was 1, then we added 6 to it, and now we've got 7. First, then now. So first there are 6, then we're going to add 1, and now there is still 7. So the same calculation, just a slightly different wording and problem really for children to think about. Here you can see the part whole model, and you can see almost at the beginnings of our bar model. It's part of our fence. 3 metres of the fence, 1 part is a light oak and 2 metres is dark oak, and we can show this with a bar model. 3 and 2 represent 2 parts and the whole is 5. 3 and 2 equals 5. This is just a practice that we might use in some of our lessons to get our children to identify independently that 2 add 1 is the same as 1 and 2, to recognise that those numbers change, but the answer stays the same. This slide's just introducing number blocks. If any of you have ever seen number blocks, you'll know that they're a really fun and informative way for children to explore number. And it starts off with 10. So that's our 10. 10, as you can see, is made up of 2 number blocks characters, 6 and 4, and this is an introduction to what is the building blocks of addition understanding, and that's number bonds. We're on the moon, 6 and 4, we couldn't ask for more. And then here is our tens frames. In early years, they often start off with 5 frames where they explore the 5-ness of 5, but here's the 10 frame. And you can see that there are 2 rows of 5 or 5 rows of 2. And that visual representation goes through children's understanding right throughout the school. I can see there's 6 there because I can see there's 5 and 1 more. I could also see there's 6 there because it's 4 less than 10. Those 2 ways of knowing that number 6 are both really important. 6 and 4 equals 10. You can see the part whole. 10 is my whole, 6 is a part, 4 is a part, and 10 is my whole. We have some Numicon here, which is another way we represent part whole models. 3 is a part, 7 is a part, and together they make 10, part of our tens frame. 3 is a part, 7 is a part, 10 equals 3 and 7. A different way to write the equation, yes, 10 equals 7 plus 3, we're catching on. So here you can see the marbles. Now notice how they're laid out. That isn't a random way that they're laid out. They're laid out to represent the tens frame so that our children can make connections between what they know about number to concrete items. There are 10 marbles, so under the pot there must be 0. 0 is a really important part in our learning about number because children need to understand the impact that 0 has on a number when we're adding 0 and also when we're subtracting. 10 add 0 equals 10. So now they're in a slightly more randomized pattern. And one of the things that would be interesting to discuss with your children is how they see this number. So are they having to count in groups of 2? Do they see this? Can they subitize? And that means just notice how many numbers there are. Can they see that as 5 and one more? So no, it's 6. Have a discussion about how they know how many are there. We really want to move away from children having to count 1 to 1 and starting at 1 each time. So that discussion about how you see a number is really important. 10 take away 6 equals 4. So 10 is my whole, 6 is a part, and 4 is a part. And again, we'd want children to draw upon what they know about number bonds to help with that calculation. If they weren't able to do that, it might be possible to count back on a number line, but this is the early stages. We're counting back 6 steps to find out that 4 is my other part. You can see that 8 is my whole, 5 is a part, 3 equals 8. So we would use these part whole with various parts of them missing to help children understand the related facts. And this is a fun activity you could do at home. You could actually have marbles, maybe, where you've got them in your hands and you work out the whole together, and then you could hide one part behind to figure out how many are there. That could be something that you could do to get that 10-ness sorted and to really explore number. 8 take away 5 equals 3. So this slide is really getting us to recognise that when we subtract the number from itself, 10 subtract 10 is 0. And see the repetition, the practice that we would give children in order for them to make a generalised statement. To make a generalised statement that when you subtract a number from itself, it gives a difference of 0, we wouldn't expect there just to be one answer. We'd want children to explore it in lots of different ways. And they would use this with resources, with concrete items. They might have 10 conkers, take 10 away. How many have I got left? They would need to experience this in lots of different situations to come to this generalisation themselves. Moving forward to more formalised maybe methods of addition, and notice we've still got the tens frame. Notice we haven't moved to a written method. In that tens frame, I can see that it's 7. I know it's 7 because it's 5 and 2 more. And the strategy that we start off with in year 2 is adding by making 10. We really rely on that 10-ness of 10 to help us understand. So I'm going to try and add 5 to 7. And what we want the children to recognise is this 5 here is going to need to be partitioned. So I'm going to partition that 5 I want to add. I'm going to partition it. So the number I want to add is the 5. And I'm going to partition it into 3 because it's the 3 that's going to make 10 and 2. So I'm going to partition my 5 into 3 and 2 to make 10. We want to make the next 10. So 7 add 5 is the same as 7 add 3 and then add 2. 7 add 3 add 2. It's exactly the same value. I've added 5, but I've partitioned it to make 10. And there's some question prompts there to help you. Now, when we're looking at subtraction, we start off with the number line, as you can see here, and we've got our 7, and we're going to subtract 3 to equal 4. What we want the children to be able to do is to experience the fluency and to be able to generalise. So now my number isn't 7, but it's 17. So when I'm subtracting 3 from 17, the answer is 14. So the calculation is staying similar. I'm subtracting 3 ones from 7 ones. And we would be hoping that it generates a discussion where the children are able to predict, okay, well, if I've got 27 now, I've got 7 ones, I take 3 ones away, I've still got 4 ones. 27, take away 3. And now we move up to 37. And it's that practice that enables children to make those generalisations equals 34. And it's just the ones digit that's changed. When we come on to adding numbers that are likely to cross 10, we always start with using resources, using Deans. You could use pennies, you could draw it, you could draw out your tens frame, 26 add 37. And the first stage in understanding is we're going to start by grouping together our tens. 2 tens and 3 tens equals 5 tens. At this stage, it's really important to distinguish between the tens and the ones. So notice when I said 2 tens, I have 3 tens is 5 tens. That will help children with their place value when we come to exchanging. Now we're going to add our ones. Notice how my 6 ones and my 7 ones are laid out, still in that tens frame to help children supertise. I've got my 6 ones and my 7 ones, and I bring them together. 6 ones add 7 ones equals 13 ones. So in this strategy, 50 add 13, I could see that together I'm going to add the 10 equals 63. I've not moved to a formal written method yet because I want children to be secure in recognising that when I add my ones together, there's a possibility that they might equal more than 9 ones. There's a different strategy some children might prefer when using addition, and that's only to partition one of the numbers. So 26 add 37. So we're going to start with 26. We're going to keep one of our numbers. We're going to partition the 37. So firstly, we're going to start by adding on the 30 of the 37. 3 tens onto 2 tens give me 5 tens, and you can see how my ones hasn't changed. But because I've partitioned it, now I know, so I've added on my 30. Now I know I need to add on my 7 ones. Going back to that make 10 strategy, I add 4 to make 10. So that's 7 I've partitioned like we talked about earlier, and I've added the 4 on. These strategies that we're talking about are often strategies that you just do in your head as a grown-up. And we need to be explicit in how we use that range of different strategies for different calculations, because fluent mathematicians can use different strategies. So I've added on the 4, and now I need to add on the 3. Gives me an answer of 63. And we would give children time to explore different methods and to discuss which they prefer and why. Now we're going to look at a column addition with no exchanging. So you can see here I've got my deans. I've got quite a formalised place value. I've got my 10s and my 1s, and I've also got the written method here. So I'm using the two side by side so children can see the concrete and how that relates to the abstract calculation. In this method, children need to know that we're going to always add the 1s first. And if they are secure with that and they want to move ahead and add the 10s first, then just let them, because if they have to exchange, that's going to give them a really interesting answer, which again is an interesting discussion. So 3 1s and 5 1s is going to equal 8 1s. Notice again how I've said 3 1s add 5 1s equals 8 1s. 4 10s add 2 10s equals 6 10s. And I've done the 2 at the same time using that really specific mathematical language. Now when we come to this addition, there's going to be an exchange, and this is when the complications start, and we need to make sure that children have got that really good grounding in what each of the digits represent. So now I've got 5 1s and 7 1s, and when I add them together, it's going to give me 12 1s. At this point, I probably would even just write 12 in the column and see what happens, see if children would be able to tell you that, no, you can only write 9 in there, that's the biggest number. So we use this word exchange. I know that 12 1s can't fit into my 1s column, so I'm going to exchange. I'm going to make sure that I take my 2 1s, which can go, and I'm going to exchange those 10 1s for 1 10. And notice how on my written calculation, I've also got the markings there. So I've got my 2 and I've got my 1 10. So now I'm going to add my 10s. So if you look at my written calculation, I've got my 2 1s. And sometimes we get children just to circle, just to prove that that's 12 if they're not sure. One of the misconceptions on this next stage is when I'm adding up my 10s, I forget to add in the 10 down here that I've exchanged, my 10 1s for 1 10. So now I add on my 4 10s and my 2 10s and the 1 10 that I've exchanged, which gives me the answer of 7 10s. It takes quite a long time and a lot of practice for children to get to this point. And notice how we don't rush straight away to assume that this is the only method for column addition. All those building blocks help children get to this point where they can do this formal written method. But don't forget, some calculations can be done mentally, can be done in a different way. So if this is something you'd like to practice with your children, please make sure that that language they're using is specific and precise to explain why they're working out a calculation in that way, and that exchanging that two, the 10 ones for 110 is clear, and they remember to add that through. If at any point you'd like further support on addition and subtraction, please do get in touch and watch the next video for a quick handy hint guide to column subtraction in a formal written method. Thank you for watching.